Hi students, good morning to all. In today's class, we are going to discuss about polarization. It is one of the important topic in the chapter wave optics, like interference and diffraction. So, my dear students, please listen the class till the end and don't skip the class. Okay, right. In the year 1865, James Clerk Maxwell proposed electromagnetic wave theory. Electromagnetic wave theory. Electromagnetic wave theory is one of the theories of light. It was proposed by James Clerk Maxwell in the year of 1865. 1865. Right. According to this electromagnetic wave theory, a light is an electromagnetic wave. Light is an electromagnetic wave. Light is an electromagnetic wave, consists of vibrations of electric field and magnetic field. Consists of vibrations of electric field and magnetic field. Please, all of you see the diagram. Right. So light is an electromagnetic wave, consists of vibrations of electric field and vibrations of magnetic field. Vibrations of electric field and vibrations of magnetic field. Right. So this is vibrations of electric field and this is vibrations of magnetic field. So according to electromagnetic theory, light is an electromagnetic wave, consists of electric field vibrations and also magnetic field vibrations. Electric field vibrations and magnetic field vibrations. Right. Here, see the diagram. Here, the electric field vibrations and the magnetic field vibrations are perpendicular to each other. The vibrations of electric field and the vibrations of magnetic field are perpendicular to each other. And also, they are perpendicular to the direction of propagation of the wave. Perpendicular to the direction of propagation of the wave. It means the angle between electric field vibration and the magnetic field vibration is 90 degrees. And the angle between electric field vibration and the direction of propagation of a wave 90 degrees. The angle between magnetic field vibration and the direction of propagation of the wave also 90 degrees. So the direction of propagation of wave, electric field vibration and magnetic field vibrations are mutually perpendicular to each other. Mutually perpendicular to each other. Right. And also the vibrations of electric field and the magnetic field in the light wave, the vibrations of electric field and the magnetic field in the light wave are confined to two different planes. Two different planes. Please see the diagram. Here, the blue color wave represents vibrations of electric field in the light wave, and the yellow color wave represents the vibrations of a magnetic field in the same light wave. Here, the vibrations of electric field and the vibration of a magnetic field are confined to two different planes. Two different planes, right? So this is vertical plane and this is horizontal plane. Okay, in the vertical plane, there is a vibrations of electric field. In the horizontal plane, there is a vibrations of magnetic field. Right. Here, the two planes also mutually perpendicular to each other. The two planes also mutually perpendicular to each other. So that is why already I told the electromagnetic wave. So light is an electromagnetic wave. It consists of electric field vibrations and also magnetic field vibration. They are perpendicular to each other and also they are perpendicular to the direction of propagation of wave. Perpendicular to the direction of propagation of a wave. And here the electric field vibrations and the magnetic field vibrations are confined to two different planes. They are also mutually perpendicular to each other. Mutually perpendicular to each other. Right. Next, it was experimentally proved that the vibrations of electric field in the light wave are the responsible for the sensation of vision. Okay, it was experimentally proved that the sensation of vision is due to the vibrations of electric field in the light. The vibrations of electric field in the light wave is responsible for the sensation of vision. The things around us is visible only due to the vibrations of electric field. Okay, is it clear? The sensation of vision is due to the vibrations of electric field, not vibrations of magnetic. The vibrations of electric field in the light wave. In the light wave. Right. So the vibrations of light means the vibrations of electricity. Okay, அப்படினா ஒரு லைட் வைப்ரேஷன் அப்படினா அது எதை மீன் பண்ணும் அப்படினு பாத்தீங்கன்னா எலக்ட்ரிக் ஃபீல்ட் வைப்ரேஷன்ஸ் தான் மீன் பண்ணும். மேக்னெட்டிக் ஃபீல்ட் வைப்ரேஷன்ஸ் அது மீன் பண்ணாது. Why? Because the sensation of vision is due to the vibrations of the electric field alone in the light field, not the vibrations of the magnetic. So the vibrations of light is nothing but the vibrations of electric field in the light. The vibrations of electric field in the light field. Right. Suppose if we neglect the vibrations of the magnetic field in the light wave like this, the light wave looks like a transverse wave. Okay, after neglecting the vibrations of a magnetic field in the light wave, the wave becomes a line like this. Okay, here this light wave is behaves like a or looks like a transverse wave. Looks like a transverse wave. So from this diagram, it is clear that the light waves are transverse in nature. The light waves are transverse in nature. Okay, you already know that there are two types of waves: transverse waves and longitudinal waves. Transverse waves and longitudinal wave. Transverse wave and longitudinal wave. There are two types of waves: transverse wave and longitudinal wave. Right. What is the difference between transverse wave and longitudinal wave? Already you learned about the transverse wave and the longitudinal wave in 11th standard. Am I right? Okay, just to recall what is the electro and the transverse wave and the longitudinal wave. What is the difference between them? Simple. Suppose when a wave is passing through a medium, any one of the medium. Okay, when a wave is passed through a medium, the particles of the medium vibrate perpendicular to the direction of the propagation of a wave. The particles of the medium vibrate perpendicular to the direction of the propagation of a wave. Then the wave is called transverse wave. Okay, a wave is passed through a medium. What happens if the wave is passed through the medium? The particles of the medium gets vibrates. If the direction of the vibration of the particles in the medium is perpendicular to the direction of the propagation of the wave means, then the wave is called the transverse wave. Okay, right. Longitudinal wave. If a wave is passed through a medium, if the particles of the medium vibrate along the direction of the propagation of the wave or parallel to the direction of the propagation of the wave, then the wave is called longitudinal. So this is a difference between a transverse wave and a longitudinal. Okay, here light wave is one of the transverse wave. Why? Because the electric field vibration is perpendicular to the direction of the propagation of the wave. So the light waves are transverse in nature. The light waves are transverse in nature. Okay. We know that reflection refraction, interference, and diffraction or some phenomenon of light. Reflection, refraction, interference, and diffractions are what? Phenomenon of light. Phenomenon means நிகழ்வு. ஒரு light உடைய நிகழ்வு. எது? Reflection, refraction, interference, and diffraction. Another one important phenomenon of light is there, that is polarization. So, polarization, diffraction, interference, refraction, and reflection are the phenomena of light. Phenomenon of light. Right. Here, the phenomena like reflection, refraction, interference, and diffraction tells us a light is a form of wave. Okay, all of you listen. Reflection, refraction, interference, and diffraction. These are phenomena of light. So these phenomena tells us a light is a form of wave. Light is form of wave. Light is a form of wave. But these phenomena does not tells us that whether the light wave is either transverse or longitudinal. Okay, all of you listen carefully. Reflection, refraction, interference, and diffraction phenomena tells us light is a form of wave, but they do not tells us whether the light wave is a transverse or longitudinal. But the polarization is the only phenomena which demonstrated that the light is a transverse in nature and the sound is longitudinal in nature. Okay, these phenomena tells us light is a form of wave, but they do not tells us whether the light wave is either transverse or longitudinal. But the polarization phenomenon is experimentally demonstrated that the light is transverse in nature and the sound is longitudinal in nature. Sound is longitudinal in nature. Right? So in this class, we are going to discuss about polarization. Polarization. Right. Before going to this, Please see the image. Right? Look at the image. Here, this is an incandescent bulb, candle flame. This is a fluorescent lamp. So these are what? Common source of light. Incandescent bulb, a candle flame, and a fluorescent lamp are the common source of light. Common source of light. Right? What is the special in these sources? So incandescent lamp, candle flame, and the fluorescent lamp emit light wave. So all these sources emit light wave. And also, this light wave consists of vibrations of both electric field vectors and also magnetic field vector. So, in the sake of simplicity, we consider only the vibrations of electric field, just to neglect the vibrations of magnetic field. Okay, right? Here, incandescent bulb, candle flame, fluorescent lamp are the common source of light. They emit light wave. It consists of vibrations. It consists of vibrations in all possible directions, like this. These sources emit light waves in all possible directions, like this. And this type of light is called unpolarized light. What is that? Unpolarized light. So the common sources of light like incandescent bulb, candle flame, and the fluorescent lamp emit unpolarized light. Because this light consists of vibration. Vibration means electric field vibrations in all possible directions. All possible direction. And this type of light wave is called unpolarized light. Unpolarized light. What is meant by unpolarized light? Simple. Unpolarized light is nothing but a transverse wave. Transverse wave. It consists of vibrations in all directions in a plane. Listen. Unpolarized light is nothing but a transverse wave. It consists of vibrations in all possible directions in a plane. In a plane which is perpendicular to the direction of propagation of a wave. Perpendicular to the direction of propagation of a wave. Right. So this is unpolarized light. So unpolarized light is nothing but a transverse wave. It consists of vibrations in all possible directions in a plane which is perpendicular to the direction of propagation of a wave. Perpendicular to the direction of propagation of a wave. Unpolarized light is also defined as a light wave which consists of vibration in more than one plane. More than one plane. The vibrations of lights exist in more than one plane, then the light is called unpolarized. So unpolarized light can be defined in two ways. So in first one, unpolarized light is nothing but a transverse wave. It consists of vibrations in all possible directions in a plane, which is perpendicular to the direction of propagation of a wave. Okay, there is a plane which is perpendicular to the direction of the propagation of a wave. In that plane, the electric field vibrations of light exist in all possible directions. In all possible directions. So such a light is called unpolarized light. Or otherwise defined as unpolarized light is a light. It consists of a vibration. It consists of vibrations of electric field in more than one plane. In more than one plane. Okay, which is called what? Unpolarized lights. Unpolarized lights. Right. Suppose if the vibrations of light is exist in only one direction in a plane, only one direction in a plane which is perpendicular to the direction of the propagation of a wave, then the light is called polarized light, or otherwise called plane polarized light. Plane polarized light. Please listen. A light consists of vibrations in only one direction, that in a plane, in a single plane, which is perpendicular to the direction of the propagation of a wave. So such a light is called polarized light. Polarized light is also called plane polarized light. Plane polarized light. Suppose if the light vibrations is occur more than one plane, then the light is called unpolarized light. Or otherwise, if the vibrations of the light is occur in a single plane, but in all possible directions, then the light is called unpolarized light. But in the case of a plane polarized light, the vibrations in that light occurs in only one direction or in only one plane. If the vibration is exists in only one plane, single plane, then the light is called polarized light. Or if the light vibration is exists in only one direction in a plane, then the light is called polarized light. Okay, are you understand what is the difference between unpolarized light and the polarized light? So once again I repeat, unpolarized light is nothing but a transverse wave. It consists of vibrations in all possible directions in a plane, which is perpendicular to the direction of the propagation of wave. It is also defined as a light wave consists of electric field vibrations in more than one plane. Which is called unpolarized light. Whereas polarized light is nothing but a light wave which consists of vibration in only one direction, or otherwise the light wave which consists of vibration in a single plane, which is called plane polarized light, or simply we can say polarized light. Okay, right. Already I told the common source of light like incandescent lamp, fluorescent lamp, and candle flame are the sources of unpolarized light. Okay, those sources or emits unpolarized light. So unpolarized light can be obtained from some common sources of light like incandescent bulb or fluorescent lamps and like candle flame. But the plane polarized light can be obtained only from unpolarized light. How? By using a three-dimensional crystal, we can get plane polarized light from unpolarized light. It means when unpolarized light is made to pass through a crystal, the unpolarized light becomes a plane polarized light or polarized light. So polarized light can be obtained only from unpolarized light when it is passed through a crystal. But unpolarized light can be obtained from all the common sources of light. And one more thing, the unpolarized light is always symmetrical about the wave direction. The unpolarized light is always symmetrical about ray direction. About ray direction, it means the unpolarized light can be split about a ray direction equally. Okay, அதாவது unpolarized lightல இருக்கிற அந்த vibrations நம்ம ஈக்குவலா அந்த ரே டைரக்ஷனுடைய ரே டைரக்ஷனை பொறுத்து நாம சமச்சீரா வந்து பாத்தீங்க அப்படின்னா டிவைட் பண்ணணும். So unpolarized light is symmetrical about a ray direction. About a ray direction. எப்பவுமே வந்து பாத்தீங்கன்னா ஈக்குவலா சமச்சீரா தான் டிவைட் ஆகும். இது unpolarized light. But a plane polarized light is asymmetrical about a ray direction. அதாவது ஒரு plane polarized light ரே டைரக்ஷனை பொறுத்து சமச்சீரா நம்ம டிவைட் பண்ணுவோம். சமச்சீரா இருக்காது, ஈக்குவலா டிவைட் ஆகாத அந்த ரே டைரக்ஷன். So these are some differences between unpolarized light and plane polarized light. So in unpolarized light, the vibrations of electric field and magnetic fields are exist in more than one plane or in all possible directions in a plane. But in plane polarized light, the vibrations occur in only one plane or in a single direction in a plane. So this is first point. Second point, unpolarized light is obtained from the common sources of light like incandescent lamp, fluorescent lamp, and also candles. Whereas plane polarized light is obtained from unpolarized lights. So from unpolarized light, we can get plane polarized. And third one, unpolarized light is always symmetrical about the ray direction, whereas the plane polarized light is asymmetrical about the ray direction. So these are differences between unpolarized light and the plane polarized light or polarized light. Okay, right. Here, the plane polarized light or polarized light is represented by like this, either double arrow or a single dot. Polarized light. So polarized light consists of vibrations in only one direction. That light can be represented by either double arrow or dot. Okay, so both the double arrow and the dot represent polarized light. But what is the difference between a double arrow and the dot? The double arrow represents a polarized light. It consists of vibration in a plane which is parallel to the plane. Suppose here whiteboard is a plane. The plane polarized light is passes like this. Means the light wave is passes like this. Means here this diagram represent polarized light. In this polarized light, the vibrations is occur in only one plane, but that vibration is parallel to the plane of the white. So the vibrations in plane polarized light parallel to the plane is represented. Okay, right. And second, the dot. The dot also represents the polarized light. But in this light, the vibrations is occur only one direction, but which is perpendicular to the plane of the white. Board. Okay, but both the double arrow and the dot represent polarized light. So double arrow represent the vibrations of a polarized light occur parallel to the plane of the board. Whereas the dot represents perpendicular vibrations of polarized light. That means the vibrations in the polarized light occur perpendicular to the plane, or perpendicular to the plane of the board, or perpendicular to the plane of the whiteboard. So polarized light can be represented by either double arrow or a dot. Double arrow or dot. Right. Whereas unpolarized light is represented by unpolarized light is represented by many double arrows like this. Okay, so this diagram represents unpolarized light. Okay, already I told in unpolarized light, the vibrations is occur in all possible directions. All possible direction. Right. The unpolarized light can also be represented by like this. Two mutually perpendicular double arrow. Okay, the two mutually perpendicular double arrow also represent unpolarized light. Why? Because if the vibrations of the electric field is resolved into horizontal and vertical component, this light becomes like this. Okay, by resolving the vibrations of the electric field in the light wave into horizontal and vertical components, this image becomes like this. So this image also represents unpolarized light. So this is front view. This is the front view of unpolarized light. But the side view of unpolarized light is represented by like this. So two double arrow with dot. Double arrow with the dot. Okay, side view. So all the images shows unpolarized light. So unpolarized light is represented by many number of double arrows or two mutually perpendicular double arrow or a double arrow with the dot. Double arrow with the dot. So here the two mutually perpendicular double arrow is a front view of unpolarized light. The side view of unpolarized light is represented by double arrow with the dot. But all the images shows unpolarized light. Unpolarized light. Okay? Is it clear? Right. Suppose let us consider a unpolarized light which is passed through a crystal. Please listen to the diagram. This is unpolarized light. Already I told the unpolarized light can also be represented by double arrow with the dot. Here, this is double arrow with the dot. So it shows unpolarized light. When the unpolarized light is made to pass through a crystal, this is crystal. Crystal. For example, tourmaline. Tourmaline crystal. So tourmaline crystal is one of the uniaxial crystal. Uniaxial crystal. Uniaxial crystal. What is uniaxial crystal? A crystal, it consists of only one optic axis in it, is known as uniaxial crystal. A crystal with only one optic axis, or a crystal with only one crystallographic axis. Crystallographic axis is known as uniaxial crystal. Okay, here tourmaline crystal is one of the uniaxial crystal. Why? Because it consists of only one optic axis or a crystallographic axis. What is optic axis or a crystallographic axis? Optic axis is nothing but a particular direction inside the crystal. So inside the crystal, there is a particular direction. It's called optic axis. Optic axis. So in this crystal, there is only one optic axis. So that is why it is called uniaxial crystal. The optic axis is also called the crystallographic axis. Crystallographic axis. Okay, right. So if the unpolarized light is passed through a uniaxial crystal like a tourmaline, the light comes out like this. That means the unpolarized light becomes a plane polarized light after passing it through a uniaxial crystal. Okay, so what is the difference in this diagram? I mean, the unpolarized lights consist of vibrations in all possible directions in a plane, whereas the plane polarized light consists of a vibration in only one direction. In only one direction. So the plane polarized light can be obtained from unpolarized light when it is passes through a crystal. It is passes through a crystal. Right. Here, when the unpolarized light is passed through the crystal, the vibrations which is parallel to the optic axis or crystallographic axis of the crystal alone comes out from the crystal. But the remaining vibrations are completely restricted by the crystal. Listen, the unpolarized light consists of vibrations in all directions in a plane, all directions in a plane. When this type of light is passed through a crystal, it consists of only one optic axis. What happened? The vibration which is parallel to the optic axis. This is the dotted line represents optic axis. So the vibration which is parallel to the crystallographic axis or optic axis alone comes out from the crystal, which is plane polarized light. Plane polarized light. But the vibrations which are not parallel to the optic axis of the crystals are completely restricted by the crystal. This phenomenon is known as polarization. Very simple. So polarization means the phenomenon of restricting of vibrations, into a particular plane, perpendicular to the direction of propagation of a wave. Or the phenomenon of restricting the vibrations of light to a particular plane which is perpendicular to the propagation of light. Okay, here the vibrations is occur in only one plane and also in only one direction. So remaining vibrations are restricted. And this type of phenomenon is known as polarization. Do you understand? So polarization is the phenomenon of restricting of vibrations into a particular plane perpendicular to the light propagation. Okay. Come on, all of you say. What is meant by polarization? Come on, anybody can say what is meant by polarization? Sri Priyadarshini, Sanmugapriya,
Sir,
hello, Sanmugapriya. Come on,
the
tell me what is
phenomenon of restricting the vibrations of
restricting of vibrations or vibrations of light.
The phenomenon of restricting the vibrations of light
into a particular plane perpendicular to the light propagation or propagation of light. Okay, come on,
perpendicular to the propagation of light.
Once again. One more time. Tell me, what is polarization?
The phenomenon of restricting the vibrations of
Light
to particular plane perpendicular to the propagation light called polarization of light.
Right. Very good. So this is what? Polarization. Okay.
Polarization of light.
Listen, எல்லா டைரக்ஷன்லயுமே வைப்ரேஷன்ல இருக்கிற ஒரு லைட்டை நாம ஒரு பர்టిక్యులர் பிளேன்ல மட்டும் வைப்ரேஷன்ஸ் கொண்டு வந்து ரிமைனிங் வைப்ரேஷன்ஸ் எல்லாமே ரெஸ்ட்ரிக்ட் பண்ற அந்த பினாமினன் போலரைசேஷன் அப்படினு சொல்லுவோம். The phenomenon of restricting of vibration into a particular plane perpendicular to the direction of propagation of light is known as polarization. Okay, right? Is any doubt?
No, sir.
Okay, thank you. Right. Now let us discuss two important terms related to polarization topic. They are plane of vibration and the plane of polarization. Plane of vibration and the plane of polarization. So whenever we are dealing about the polarization, it is necessary to know about the plane of vibration and the plane of polarization. Plane of vibration. Second one is plane of polarization. Plane of polarization. What is plane of vibration and what is plane of polarization? Simple. A plane which is parallel to the optic axis of the crystal. A plane which is parallel to the optic axis of the crystal, in which vibrations occur. Is known as plane of vibration. Please see the diagram. Here, the plane A, B, C, D is called the plane of vibration. So plane of vibration is nothing but a plane which is parallel to the optic axis of the crystal, It contains vibrations in it. Is known as a plane of vibration. So plane of vibration is a plane which contains vibrations in it, which is parallel to the optic axis of the crystal. So in this diagram, the plane ABCD plane represents plane of vibration. And second term, plane of polarization. Plane of polarization also a plane which is perpendicular to the plane of vibration. In which there is no vibrations occur, only the light propagates through this plane. Okay, here see the diagram. The plane P, Q, R and S. PQ or S plane is the plane of polarization. In plane of vibration, only vibrations occur, but in the plane of polarization, no vibrations occur. No vibrations in the plane of polarization, and the light vibrations is exist only in the plane of vibration. So a plane which is containing vibrations in it, and which is parallel to the optic axis of the crystal is known as the plane of vibration. A plane which is perpendicular to the plane of vibration. A plane which is perpendicular to the plane of vibration, in which there is no light vibration, which containing only the direction of the propagation of the light wave, which is known as plane of polarization. Plane of polarization. Here, ABCD plane represent the plane of vibration, because in this plane there is a vibrations of light is exist. So that is what is called the plane of vibration. But in the plane of PQRS, there is no vibration, only light propagate through the plane, but which is perpendicular to the plane of vibration. Perpendicular to the plane of vibration. So which is called plane of polarization. Plane of polarization. In plane of polarization, no vibrations of light wave. But in the plane of vibrations, there is a vibrations of light wave. But in both the plane of vibration and the plane of polarization, the light propagation is there. The light not only propagate through the plane of polarization, but also the plane of vibration. But the only difference between plane of vibration and the plane of polarization is that in plane of vibration, there is a light vibrations exist, but in the plane of polarization, there is no vibrations of lights. There is no vibration of lights. But the angle between the plane of vibration and the plane of polarization is 90 degrees. They are right angles to each other. Okay, come on, tell me what is the plane of vibration and the plane of polarization?
A plane in which vibration.
The plane which is parallel to the optic axis of the crystal in which a vibration occurs is called plane of vibration.
In which vibrations occur is known as
Plane of vibration.
Plane of vibration.
Plane of vibration. Plane of polarization.
The plane which is
Perpendicular to the plane of vibration.
Right. A plane which is a right angle
in which no vibration
plane
takes
of vibration
place.
is known as the plane of polarization. So what is the difference between plane of vibration and the plane of polarization? What is the main
In plane
difference?
of vibration, vibration exists.
Vibration exists in
Okay,
plane
here,
of polarization.
vibrations means what? Vibrations means what? Electric field vibrations of light. Okay, light wave consists of electric field vibration and also magnetic field vibrations, you know.
Yes, sir.
Okay, so for our convenience, the magnetic field vibrations are just neglected. So only we consider the electric field vibrations. Okay, if any plane which consists of light vibrations in only one direction, then the plane is called the plane of vibration. Plane of vibration. But the plane of polarization means a plane which is exactly perpendicular to the plane of vibration, in which there is no light vibration. It contains only the light propagation. Light propagation. So this is called plane of polarization. Okay. Right? Is any doubt from a polarization region?
No, sir.
Okay. Please, all of you, once again go through the topics which are discussed in the today's class. If you have any doubt, please call me or send message to my WhatsApp number. Right? Thank you, students. We will see in the next class. Shall I give some imposition? Okay, please you write what is polarization of light, plane of vibration, plane of polarization, plane of polarization. Okay, right? So this is for your today's assignment. After writing it, please send it to my WhatsApp number. Right. Thank you, students.